Hello guys, welcome to yet another tutorial series. We are still on the series of PIR motion sensor. In this case, we'll be talking about how we can use the PIR motion sensor with our Arduino Uno using OLED display. So basically, in this one, we're going to be integrating an OLED display. What we'll be doing right now is just use OLED display to indicate the radar's display of this PIR sensor we have here. The system is going to scan in form of a radar. Once the motion is detected, it's going to display on the screen that motion has been detected. So right now, this is just the basics. So let's just dive into how we can do the connection. I'm going to show you a video display of how it works. But before then, I want us to go through a phase-by-phase connection in such a way that you'll be able to at least replicate this project on your own. So right now, let's just dive into the connection. So in this very tutorial, we'll be requiring some basic components in order for us to be able to carry out this project. So what we'll be requiring first is Arduino Uno. We'll be needing our OLED display. In this case, we are using the I2C OLED display. In this case, we use a 0.91 inch OLED display. You can also use others. All you just need to do is to change the display size on your code and it will work perfectly for you. But in this case, what we are using is 0.91 inch OLED display. So we'll be using our major sensor in this project, which is our PIR sensor. In this case, this is the sensor on the screen. Basically, the pin out of this sensor, you will understand if you already went through the first part of this tutorial series, which I explained the pin out. Basically, this is negative, this is out, and this is positive. So basically, there's really not much there. You can just type on your Google the pin out of this PIR sensor, and you will get the pin out. So when you're doing your connection, you won't go and wire it wrongly and burn off the circuit. So our next is jumper wires, because we need jumper wires in order for us to do this connection from the PIR sensor to our Arduino and all that. So right now, let's do the circuit connection from phase one. We'll do it phase by phase. So first, we're going to connect the OLED display to our Arduino. After the OLED, we'll connect our PIR sensor. After that, we'll upload the code and we'll do a video representation of how it works. So right now, let's just move on. So here on the screen, our ground on the OLED display has been connected to our ground on our Arduino. So the next, we're going to connect our VCC. So VCC has been connected now. VCC has been connected to VCC. Mind you, when connecting this OLED, do not connect to 5 volt. If not, you're going to damage this OLED right away, because this OLED uses a 3.3 volt. So basically, as you can see, I indicated here 3.3 volts. And if you zoom into this, you're going to see that it's allocated to 3.3 volt of this Arduino. We have 5 volt, we have 3.3 volts. So please do not connect it to V-in, because you meant to connect it to V-in of this Arduino, you're going to burn the OLED display. That will be costing you a few bucks extra. So to avoid that mistake, which you might not have the access to just go get a new one immediately, in some cases you will need to order it if you don't have a shop where you can get it close to yourself. So it will not be wise for you to order once you get to you on your first trial, you burn it. So 3.3 volts, don't forget, that's why this is indicated here. So after that, we connect our SCL. Now our SCL has been connected to A5, the analog pin 5. SCL has been connected. So the next is our SDA, which will be connected to analog pin 4. So SDA right now has been connected to what? Analog pin 4. So currently our circuit connection for the OLED display to our Arduino is fully complete. Now we have to move on to our PIR sensor. This is the major sensor for this project. We should be doing the heavy lifting. So right now we're going to connect the ground. This is the ground. first pin here, and this is the VCC, the last pin. The middle is the pin out. This is where it receives signal from. Rather, the signal that will be captured on this sensor will be sent out from here to the Arduino, whereby the Arduino will pass the corresponding signal to this OLED. So that's why it is called pin out. So it's going to be feeding the once you connect this sensor itself to plus 5 volt and ground, automatically it starts working. So in order for us to get the signal that comes from here, we have to feed the pin out towards our D2 here, digital pin 2. So first of all, we have to connect our ground and our VCC in order for this to work. So let's connect the ground. The ground right now has been connected to ground. As you can see, I didn't use the ground here. We also have a ground here on this other side of the Arduino. Instead of going this way, we just use a closer route. So the next one is to connect the VCC, which is this one. Now the VCC has been connected, as you can see. So the next on our list is to connect the pin out, which is this one here. We'll connect it to pin 2. So pin out has been connected to pin 2. So at this point in time, our circuit is fully connected. If you do this on your breadboard just the way it is here, the reason I have to use this pictorial diagram instead of schematic is in order for you to understand what you're doing, because most persons have reached out to me that they don't really understand the schematic diagram because of the fact that they are not really that good with electronics. So I use the exact physical diagram in the wiring so that you will understand. What you see here is exactly what you see in your hand if you are having this exact model. If you're having the other one, all you need to do is to remove the lid on top, the plastic cover, and we see the pin out. It is clearly written there, ground, VCC, and out. So it is not difficult. In this case, what you see here is what you're going to see physically if you're having this device, this very OLED screen on your hands. So the circuit diagram is as simple as it can get. It can't be more simpler than this. So you just do the wiring. It doesn't matter with the one you start with. You can start with this, you can start with this. It doesn't matter. The important thing is that as long as you're connecting wires, they have complete continuity. Once you do this, the next thing is to do is what? Go to our Arduino upload. What we'll do next now is move to our Arduino upload. So guys, this is the basic code we'll be needing for this project. And once we've uploaded it, we're going to see how it performs physically. Because right now, just as we did the connection, I was also wiring the physical connection on a breadboard, which we're going to be seeing in a moment. So basically, this is the code. What you need to do is basically include these three libraries, this, this, and this. These three here, as you can see, this Adafruit GFS, you need it. Then Adafruit SSD 1306. You also need the this math.h library. So if you're not having it already installed, what you just need to do is to come here and you can just copy this Adafruit underscore GFS, put it here, load it. Let me just do an example for you. What you need to do is to copy, paste it here, then you wait for it to load. So you can see. So this is it. Adafruit GFS library. It's already installed. That's why it's showing remove. In your case, if it's not installed, you just see an install button like this. You hit the install button and wait for a few seconds for it to install. As long as you have a good network, it's going to install right away. So right now, I already have this theory library installed. So what I need to do is collapse this. All right. So right now, I'll go to tools, go to board, Arduino AVRO, or select Arduino Uno. That's what I have. So go to tools again, go to COM. This is my current Arduino port. The Arduino that's already connected to mine is on COM 12. So I'll select COM 12. So what I need to do next is upload. So I'm just going to upload the code. So once you hit upload, as you can see, it's showing compiling sketch. Once the sketch has been compiled fully, what it's going to do next is
So guys, right now
practically
what
upload
we'll
the
be
code.
doing is
So
I'm
like I
going to be
said
showing
earlier,
you
that
a
if you
video
have
operation
a
of
bigger
how
screen
the
size,
hardware
this is the
works
screen
with
size for it,
Arduino
the
Uno,
screen
which is our
height. If you
PIR
have a bigger
sensor.
one,
So let's do that right
you
away.
you you alter these two parameters. You just look for the height of your screen, the width and the height. You put it here, upload the code. It's going to work perfectly for you. But if you are using the 0.91 inch, you don't need to alter this code. It's going to work directly. If you are using a 3.1 inch OLED display, for instance, you need to alter this, because if you upload it, it's going to start having like a broken screen for you. The display is going to start having a broken screen display for you because the screen size was not properly addressed. So everything will start collapsing on a single line. So in order for you to avoid that, you just alter that. Basically, you don't really need to do much with this code. All you need to do is to upload it, and the code will do basically the job it's meant to do. So right now it has been uploaded. So let's dive into seeing how the hardware works.
Welcome back, guys. So this is an advancement or a replica of the initial one that was done. Now I told you I was going to repeat this same process using an OLED display. This is zero point 0.9 OLED display. So what we just did here is try to replicate the same system we have here. As you can see, this system right now is just triggering left and right because of the fact that I'm moving a lot. So this one here is a replica of what we already have. So right now, as you can see, this is the OLED display. It's scanning right now for motion. It detected motion for a bit. Again, that is because my hand moved. So right now I'm just going to try and do, as you can see, motion detected. Once I move my hands close, it detects motion. Motion detected. Motion detected. So basically it works just like this one. The only difference here is that we're using an OLED display. So if you have an OLED display, you can as well carry out this project without having to feel bad that this is one that was done and yet you are not having a 16:2 LCD display. But if you're having this, you can as well do this and also feel fulfilled. That's the reason for this. So watch out as we'll be advancing this furthermore in this project, because the aim of this project series is to design as many DIY projects as possible with this very sensor here. This is a PIR sensor. This is it here, a bigger one for clarity. This PIR sensor can be used for a lot of projects. Mostly we find them in our homes, in our office, but we don't really know what they are. And this is what does the magic. The situation whereby you enter a room, automatically light turns on, basically detecting your presence. This is the sensor that does it. Automatic street light that turns on when it is detecting motion. Maybe you're coming, all the lights start going on for you to see. As soon as you are going, they are turning off behind you. This is what does it. This very sensor here, as you can see. So this project series is going to cover a lot of projects which we're going to be covering in this series. So right now, let's just wrap up this one. I'll move to the next one. So be expecting the next video. I'm not going to say what the next one is going to be, so that will be a surprise. Look out for the next video. Subscribe, like, share our videos so that whenever we post, you will be able to see our videos. Also hit the notification bell so that whenever there's a new video posted, you'll be notified immediately on your notification bar. Thanks for watching. See you in the next video.